Welcome back, everybody. Today we're going to start up Chapter 5, which is all about solving equations involving trigonometry. So as in solving trig equations, as in solving equations with trig in it. And what we're going to do to begin with in 5.1 is start off with kind of some basic stuff that's going to lay the groundwork for the rest of the chapter. We're going to start by talking about inverses of trigonometric functions. Okay, and we're actually not going to quite get to the inverse part with this video here. That's part 2 of the lesson. Today what we'll do is look at some very basic trig equations and, like we said, start laying a foundation for this chapter. First thing I want to show you how to do in this chapter is how to solve trig equations using a calculator. Okay, the pictures or the graphs our calculator gives us are going to give us a really good idea how these equations work and also what the issues are as we go through kind of the rest of the chapter. So let's go ahead and do that. Problem 1 says, use a calculator to solve for x on the given interval. And I want to solve cosecant x equals 2.7 for x between pi over 2 and pi. Right, so in other words, we want to figure out what x or what angle makes our cosecant function equal to 2.7. And we're going to say our angle has to be on this interval here. Okay, let's pull our calculators up. Make my face go away here. Now, usually what we do when we're solving equations with the calculator is we'll take both sides of the equation and plug them into different y equals equation on the calculator. So for example, for y1, I'm going to plug the cosecant of x in. Now, we've got a problem. I don't see the cosecant button on my calculator, but I suppose what I can do is use an identity from last chapter. I know cosecant's the same as 1 over sine, so instead of cosecant, I'm just going to say 1 divided by sine of x. All right, that's the same as cosecant. And then for equation 2, we'll just say y equals 2.7. And then the second, we'll graph these and figure where they intersect at. Okay, now a couple of things we need to do before we do that. First off, let's make sure we're in the right mode. Since I want my answer between pi over 2 and pi, that means I want a radian answer. So let's make sure we're in radian mode. If I hit my mode button and scroll down between radian and degrees, yep, I want the radians lit up. Looks like I'm already good to go. Okay, then the other thing we're going to need to do is come up with a good window to work with these trig equations. Okay, because if you remember our graphs of trig functions, they don't go on the x-axis by 1, 2, 3, 4. They go by pi's, pi over 2's, 2 pi's, that kind of stuff. And the calculator has a preset window for graphing trig. If I hit the zoom button and scroll down to option 7, Z trig, whoa, try that again. Option 7, Z trig, zoom trigonometry. When I hit enter, I'm going to get a x and y scale that give me a nice picture to work with here. So let me make that picture bigger here quick. Let's try that. Yep, there we go. Okay, now how does this picture work? Okay, I've got my cosecant curve in blue, and then my 2.7 in red. And like we said, the zoom trig, the big thing it does is it gives us a nice x-axis for a scale. It looks like one cycle of this cosecant function starts to repeat here. So now that right here is 2 pi. And if I split this apart, we get a pi in the middle and a pi over 2 right here. So the big thing to get with the zoom trig is that the scale is going to count by pi over 2's. All right, so the reason I need to specify where I want my solution is if I want to know where these two graphs intersect, let's take a look. There's one solution here, one here, one here. So we're at 4, 5 that are shown on the graphs. If I kept going to the right, if I kept going to my left, I'd end up with an infinite number of solutions to this equation. Now I'm going to say I only want one of them. I want the one between pi over 2 and pi. That's why we gave you that range. So in other words, I want the solution between these two values. I want this second positive solution. Okay, so let's pull the calculator back up to find that. Reminder how to find intersections. We'll go second Above trace is calc. We want to find where these graphs intersect, so we'll say option 5. Let's scroll to the right so I can find my cursor. Okay, first curve looks like I'm on the cosecant curve, we'll say enter. Second curve looks like we're on the red curve, we'll say enter. And then for the guess, I just need to make sure I'm as close as I can be to the solution I'm looking for. Like we said, we want that second positive one, so we'll say enter. And that gives us y is equal to 2.7 when x is equal to 2. We could say 8. And we'll say rads just to make sure we know what type of units we're dealing with. Okay, B is the same idea. Plug this equation into your calculator. Okay, use the intersect function to find the intersection, find the solution. Okay, you'll use the same window. Why don't you take a minute, hit pause, give that a shot, then hit play to check your answer. All right, let's give this a shot. Get our calculator pulled back up. Cotangent, that's the same as 1 over tangent. And then we want to know where that's equal to a negative 3.1. Should just be able to graph that. Zoom trig, same zoom. Okay, you can use the same zoom for all these functions, for all these problems. Okay, again, I have an infinite number of solutions. There's a whole bunch of spots where this red line hits the blue lines. But I want the one between negative pi and 0. Okay, well, if we're counting by pi over 2's every time, if I count backwards, we get a negative pi over 2, negative pi. So here's negative pi. Here's x equals 0. That means this is the solution I'm looking for. Okay, this first negative solution. So again, second, calc. Option 5 is the intersect method. Let's find my cursor here quick. Okay, first curve's in blue, second curve's in red. Take a guess, we'll scroll over, hit enter. And we end up y is equal to negative 3.1 when x is a 0.3, we could say. Rads. Pop back in here. All right, on to problem 2. Problem 2, we're just going to do the exact same thing, solve some simple trig equations, but this time do it by hand without a calculator and come up with exact solutions instead of round solutions. Okay, so problem 2, solve for x on the given interval. I want to know what x value makes cosine equal to a negative root 2 over 2. Okay, for x between pi and 3 pi over 2. Now I need this second part, I need this interval for my solution beyond, because just like we saw with the graphs, there's going to be an infinite number of solutions. We want to find a specific one here. Okay, and this is actually something we've done in class before, basically working backwards, figuring out what angle gives us a trig value. We're just looking at through the perspective of trig functions this time. All right, so let's go to our angles in standard position. And first thing we want to do is figure out which quadrant this solution is going to be in. Okay, as we rotate around our coordinate system, I'm going to put an angle in standard position here to start off with. I know that half a rotation is pi. Okay, same thing as 180 degrees, or here's my pi. Okay, 3/4 of a rotation is 270 degrees, in other words, a 3 pi over 2. I suppose we could also say up here is pi over 2 for 90. 0 is the same thing as 2 pi. So I want my solution between pi and 3 pi over 2. In other words, I want my solution to be in this third quadrant here. Okay, so the angle we're talking about, the x we're looking for, is going to be one that puts us into this third quadrant. All right, that's my x. Okay, to solve for that, what we can do is work backwards. We want to make a reference triangle here. Okay, I suppose one thing to recognize with this one is, remember, when I see this negative root 2 over 2, that's the same thing as negative 1 over root 2. Okay, if I unrationalize it, okay, if I rationalize 1 over root 2, I'd get the root 2 over 2. Okay, I'm going to do that because that's going to help us think in terms of our special right triangles. We know the cosine is the adjacent over the hypotenuse. So that means for this reference angle here, let's call it alpha for now. We know the adjacent side's a 1. Hypotenuse is a root 2. Okay, 1 root 2. That means my other side has to be a 1 as well because this is my 45, 45, 90 right triangle. And I suppose both these ones would be negative because we're talking negative x and negative y. Okay, so my reference angle then is 45 degrees. I figured out what type of triangle I'm talking about. For my answer then, my x, we want this angle in standard position, which in this case would be 180 degrees. All right, plus that 45 degrees we just found. Okay, so we go 180 plus another 45, which gives us a 225 degrees. And then that's a degree. I want an answer between pi and 3 pi over 2. In other words, I want an answer in radians. So I'm going to finish by converting that. We'll multiply by pi over 180 degrees. And I know that's equal to 5 pi over 4. Okay, I didn't just calculate it in my head. What I did is I know that 45 degrees is pi over 4. Okay, so a pi would be 4 pi over 4. Add one more, we end up with 5 pi over 4. Okay, so 5 pi over 4 is the x value between pi and 3 pi over 2 that satisfies this equation that makes the cosine of that angle equal to negative root 2 over 2. Okay, that's the basic idea for solving these by hand. Part B is the same idea. I want you to take a minute, pause the video, work through that one, and then hit play to either check your answer or to get some help with it, I suppose. All right, so here we go. Tangent of x equals negative root 3. And it's going to be helpful to think of that as a negative root 3 over 1. Okay, for x between pi over 2 and pi. So again, we're going to angles in standard position. And I know that pi over 2 is right here. I know that pi is right there. Therefore, we're looking for an angle between the two of these. So we're talking about an angle that goes to this second quadrant. That's the x I'm looking for. Okay, let's make our reference triangle. We've got the reference angle here. And the tangent is opposite over adjacent. That means my opposite side needs to be a root 3. Okay, the adjacent side will be a 1. Okay, root 3, 1, 2 is the other side we're talking about because we're talking about our 30, 60, 90 right triangle where it's the 60 degrees across from the root 3. Now, as far as negative signs go, this negative isn't stuck to the root 3. It's actually beyond the 1 here because we're talking negative x direction, positive y direction. Okay, then as far as an x, then we know our reference angle is 60. The actual angle we're looking for will be 180 degrees. And in this case, since we're short of getting all the way to 180, we'll say minus 60, which is going to be equal to 120 degrees. And if I convert that by multiplying by pi over 180, or counting by pi's, I know I'll get a 2 pi over 3. And I know that one because 60 is pi over 3. I'm 1 pi over 3 short of a pi, therefore I have 2 pi over 3. Okay, you can always convert that with a calculator, but it's helpful to think in terms of pi's with these. All right, we've also got a part C for this one. Now, part C is just a special case of what we've been working on. So let's show you what's going on with part C. We want to find cosine x equals 0 for x between 0 and pi. Now, I could approach that the same way I've been doing. It's an ugly y-axis, but oh well. Where we're looking for an answer between 0 and pi. So we're talking this part of the coordinate system. Now, the trick with this one is I want to figure out what value makes cosine x equal to 0. In other words, I want the adjacent over the hypotenuse to reduce down to 0. I can't have a triangle like that. Okay, meaning what type of angle do we have? Well, what that means is we have a quadrantal angle, either a 0 degrees, a 90 degrees, or a 180 degrees. It's going to be one of these three. Now what I could do is I could evaluate cosine for each of these and figure out which one it is. I'd say with this type of problem though, where what we're equal to is something I can't have on a triangle, like a 1, a -1, or a 0, is go to the graphs of these equations instead. Okay, so what I mean by that is let's graph out one cycle of a cosine wave. Remember, cosine was our one that started at top at 1, goes down to -1, and then comes back up to 1. So let's go 1, -1, and the cycle lasts 2 pi units. Okay, now I want a solution between 0 and pi. Okay, here's my 0, here's my pi. Okay, such that cosine x equals 0. In other words, what x value makes my cosine equal to 0? Well, that's going to be this intersection right here where my cosine graph crosses the x-axis, which is just at a pi over 2. All right, so my answer for this one is pi over 2. Okay, pi over 2 is the angle that makes cosine x equal to 0 between 0 and pi. Okay, like I said, I could get that by checking the different quadrantal angles. I think it's a lot quicker just going to our sketches of these different waves here. Okay, problem 2, part D is the same thing. It's another special case, okay, where I'd recommend using the waves of the functions. Once again, take a minute, pause the video, work through that one, and then hit play to check your answer. All right, so for D, we want to solve sine of x equals -1 for x between pi and 2 pi. Again, since we're talking about something I can't have a right triangle for, I can't make a right triangle where the opposite side over the hypotenuse is equal to -1. Okay, hypotenuse has to be bigger, can't happen. So that's why I know I'm going to go to the graph of the sine wave. And these will be just rough sketches, not a lot of details necessary. Sine was our one that started at the middle and went up, down, and back up. There's one cycle of our sine function. Just like the cosine, it runs between 1 and -1. It ends at 2 pi, okay, as a period of 2 pi as well. Okay, I know the middle of that is a pi, so I want a solution between pi and 2 pi. In other words, on this part of my graph, that makes the sine of x equal to -1. So in other words, I want this x value here, sine of x will be -1, halfway between pi and 2 pi. In other words, at 3 pi over 2. All right, so when x is 3 pi over 2, okay, sine of x will be -1. And like we said, 3 pi over 2 is between pi and 2 pi. All right, so that's part 1 of section 5.1. In part 2, we'll actually get into the inverse piece of it. Now that's going to build directly off of what we're doing here. So you're going to want to get some practice in. You're going to want to make sure you have this stuff figured out before we move on to the second video. So give the homework a shot. Let's say I showed you how to do problems 1 through 7 for now. Okay, so get through 1 through 7. Get help if you need it. Ask questions if you need to. And then you can pick up with part 2 of the lesson in the next video.